Okay, so let's start off basic with synthesis reactions. Okay, so synthesis reactions, in order for you to know what reaction is synthesis,
A plus B was AB.
yes, A plus B equals AB, or yields AB. What is AB? What does that represent? Reactants, yes, but more specific. Elements.
A and B.
Yeah, right. A plus B are elements. So, for example, Na plus F2. What are those representing? My reactants, right? The A and B part. Does that make sense? So A would be Na. Yes, exactly. And you would cause charges to get AB. So, can you tell me the charge of Na?
Na is plus 1.
And F is?
Minus 1.
Right, so what's the formula?
NaF2.
No 2. When you cross the charges, it's NaF. This guy won't carry over. So you just get that from crossing charges.
If we put the 2, it's wrong.
Right. NaF only. Okay? So that's AB. Now, I have to put the states of matter. How do I know the state of matter of this compound? Okay, so NaF, I want to go up here. So NaF is the compound. So I have to look for either Na or F anywhere on the left side. Do you see it?
Aqueous.
Do you see Na or F?
Yeah.
Where?
Na.
In the second one.
Yes, so Na is soluble. What does soluble mean?
There's no
Aqueous.
exceptions.
Aqueous. And there's no exception, so it's aqueous. Soluble means aqueous. If there was exceptions and that was ours, what would we have to do?
You have to put.
It would be insoluble then. So then I would put solid. Does that make sense?
Oh, when there's an exception, it's solid.
It's the opposite.
And when it's in a
No,
gas?
opposite. Because this right here is solid, and these exceptions are soluble. They're aqueous.
Okay, so when it is CO3 2 negative, and it's an alkali metal.
Right. So if I were to give you Na to CO3, Na is an alkali metal. So this compound would be what? A CO3 is insoluble. That means solid, but it's bonded to an alkali metal, so that makes it soluble. So this is actually aqueous. But if I didn't have Na here, and let's say I had a different compound, like iron, for example, is iron an alkali metal? Is iron NH4? No, so it's not any of the exceptions, so it just stays being insoluble, solid. Okay?
But that can be a reactant because it has a 3. The 3 doesn't carry, no?
What do you mean? No, CO3 is carbonate. It's a polyatomic ion.
Oh, that 3 carries?
Right, it's part of the formula. Okay? So, ours is aqueous, we said, right? And now I have to balance the reaction. Is it balanced?
No.
How do I balance it?
Line to the middle. Oh, no, I don't know
Put
the
a 2
easy way.
in front of the
Like
NaF.
Look at it. Look at it. What's not balanced?
The F.
So how would I fix that?
Put a 2 in
Put a
front
2.
of F.
That's it. That's the fast way.
Yeah, but it sucks.
So you said put a 2 to change F to 2, right? So that balances this.
And then NA is, now you put a 2 in front of NA.
That's literally what you just did it.
Yeah, but that's an easy one, not on the hard ones.
Same thing. Okay, so again, how do you know when something is synthesis? You have 2 elements as the reactant.
Would we have to say that it's synthesis?
Right. So then this is it. Put S for synthesis, or you can write out synthesis. And then do what we just did, and that's all you have to do.
Can you,
Well, these will be given to you on the quiz. So I'll give them to you. You only have to do the states of matter for the products that you predict.
what happens if it's aqueous and solid?
I mean, that doesn't tell us like what's going to be. No. It doesn't tell
We
us.
use the chart.
Right, you have to use a chart.
But if it's aqueous and aqueous, it's going to be aqueous.
Not always. Mhm.
What if it's solid and solid?
Not always. That's why it's not predictable. You have to look at the chart.
And you're not going to tell us gas.
Right. So there's no gases on the quiz. All right. Next type of reaction is combustion. Okay. Right. So in order to be combustion, there's two different scenarios. Okay. I could have CXHY.
Recording?
A hydrocarbon.
Yes, I'm recording. Right. Hydrocarbon reacting with oxygen, or just a plain element reacting with oxygen. I'll tell you what that means in a second. Okay. So X and Y are just numbers. So any number of carbon, any number of hydrogens, I could have CH4, I could have C3H8, any type of, this is called a hydrocarbon because I have hydrogen and carbon in it. Any hydrocarbon reacting with oxygen will always make CO2 and H2O all the time. Every single time. So look. If I gave you this problem.
CO2, H2O.
This is a hydrocarbon, right? It's a compound made up of hydrogen and carbon. Every time I have a hydrocarbon reacting with oxygen, I get the same products every time. And it doesn't matter how many carbons and how many hydrogens I have. Anytime they react with oxygen, I will always get CO2 and H2O.
That's not hydrocarbon. That's carbon-carbon.
Oh, yeah. Thanks. I will always get CO2 and H2O every time. Does that make sense?
What if it's O2 plus plus hydrocarbon?
Like putting the O2 first?
Yeah.
Same thing.
Okay.
Mm-hmm.
And what if it's hydrocarbon plus oxygen plus another?
Different.
It's different?
Yeah. Okay, I could also have even, carbon with hydrogen and oxygen. And it reacting with oxygen would still give me CO2 and H2O.
But isn't that C3H6O5?
Yeah, so, no. No, not a state. This is actually glucose. So, even if my hydrocarbon has an O with it and it reacts with oxygen, it's going to give me the same products every time, CO2 and H2O.
And if it's CO plus H?
No. Has to be a hydrocarbon with oxygen, O2
yeah,
by
yeah.
itself. O2 has to be by itself.
Okay.
Good? So does that make sense? And then balance it. Another type of combustion can be whenever I just have an element. So this is just a plain element. So let me just put A instead, actually. So plain element with oxygen.
Yeah, A is better.
Right. So then plain element,
A and B.
yeah. Plain element with oxygen, that's just what? Synthesis. Make sense? And then you just,
That's synthesis.
right. This
A
would be,
plus O2 is synthesis.
right. And combustion.
Yeah.
Both.
Wait, combustion is when there's an O2 alone.
Oh, yeah. O2 alone. That's what makes it combustion, is having O2 by itself. Okay, cool. And then, of course, you balance it. So remember, in combustion, everything's gases because of the heat.
Yeah, combustion.
For this one, depends. This one, I have a metal oxide. Okay, and so if I were to give you a synthesis reaction like this, it would be, this is a metal with oxygen. Why? Because you cross the charges to get the formula. All metal oxides are solids. I'm going to give that to
You
you.
mean combustion? That's synthesis and combustion.
Right, both.
It's combustion because there's an O2 alone.
And it's
And when
synthesis.
there's an O2 alone, it's metal and oxygen. Always.
And if it's O2 alone, it's metal with oxygen. If it's synthesis, yes.
Okay. When it's combustion and synthesis, it's metal and then oxygen.
Yes.
Which is metal.
Yes, perfect. And that will be a solid. Okay? But I'll give that to you on the quiz, actually. Okay, next, decomposition. Any questions on the other one?
Decomposition is AB equals A plus B. Right?
Nice. Okay, nice. So AB decomposes into A plus B. Okay, there are 4 types, but I'll only go over 3 because the 4th one won't be on the quiz. So just to save time. Okay, so we can have a metal chlorate decomposing.
Carbonate and
Nice.
metal oxide.
You already know this.
Oxide or oxide?
A metal hydroxide.
Chocolate.
Okay, so these compounds, when they decompose, they have rules. This is what I mean by rules. So here's a metal chlorate. Okay, this is a metal carbonate.
Chlorine is ClO 3 2 negative. No?
Just negative, not too negative. And then here's a metal hydroxide. Do you know what I mean when I say like metal hydroxide, metal carbonate? You guys understand that?
Yeah.
Okay.
It's a metal and a carbonate.
And a carbonate, a metal and a chlorate, a metal and a hydroxide. Okay? So metal
I mean chlorate is ClO
3 minus.
Oh, and carbonate is CO3.
2 minus.
2 minus.
Okay, all metal chlorates decompose into the same things every single time. Okay, this guy. They always decompose into a metal chloride and oxygen. Okay, what does that mean? Well, what's a metal chloride? If a metal oxide is a metal and oxygen, what's a metal chloride?
Metal and chloride.
Right, what's my metal here?
Li.
Okay, and then what's oxygen's charge?
O2.
2.
Minus.
So when I cross this, what do I get?
Wait, why oxygen?
Li2.
So sorry.
Yeah.
Nice.
LiCl.
Yes.
CLO.
No, chloride, not chlorate. This is just plain chlorine. That's what chloride is, plain chlorine.
What? But isn't chlorine and chloride, that's 2 polyatomics?
No, chloride is just chlorine.
What are the 2 polyatomics? Chlorate and
So there's ClO3 minus chlorate,
yeah.
chlorite.
Chlorite.
Yeah.
I got confused. Chloride.
Okay, I see what you mean. If it's IDE, it's just a plain element.
Okay.
So what's the compound here?
LiCl.
Okay, so that's one product. And oxygen is just what? O2. Why 2?
Diatomic.
Brinkelhoff.
Brinkelhoff diatomic.
And
Okay.
oxygen is like I already got used to it just being O2.
O2, yeah, good. Okay, and then of course you put the states of matter using the what?
The thing.
The chart. Everyone, you guys are cool with that? You want to go over how to do that?
Wait, Li. It's aqueous. There's no exceptions.
Uh-huh.
And oxygen, it's always what?
Gas.
Yeah.
Mm-hmm. That
But you're
sheet
gonna tell us
only... No. You have to know that. That sheet you have only lets you do compounds. For the elements, this is what you want to look at. So all the pink are solids.
Are you gonna give us that?
No. The 2 blue is metals. It's not hard. All Brinko, this whole like L shape. This whole L shape
And
with
CO.
chlorine and hydrogen gases, and then just Br. You don't care about that guy. Br is liquid, and then everything
Green is
else is
gas.
solid.
Blue is liquid.
So it's still a pink.
And pink is
Solid.
solid.
Mm-hmm.
Okay, wait. Let me take a picture.
Want to put in the group chat?
Yes.
Yeah.
Please.
Thank you. Okay, perfect. So does everyone understand what a metal chlorate decomposes into?
Yeah.
Okay, good. Next, metal carbonates. So they are a little bit different. They decompose into not metal chloride, because I don't have chlorine, but metal oxide.
Nah,
And-
but it's supposed to be carbon.
Carbon dioxide.
CO2.
Nah.
No, it makes sense. Look, whenever we write everything out. Okay, so what do you think a metal oxide is again?
A metal and oxygen.
Right. Well, who's our metal?
K, potassium.
What's K's charge?
Plus.
K is plus 1.
Yes, and then oxygen.
Oxygen is
2 minus.
2 minus.
What's the formula?
K2O.
O.
Perfect. And what's carbon dioxide, obviously?
CO2.
CO2.
There you go. And then, of course,
It's a gas.
carbon dioxide's a gas, and all metal oxides are
O solid.
solid. Okay, I'm going to give that to you on the test.
And in the test,
Mm-hmm.
how is it gonna be structured? Like it's like this,
Exactly like that.
and where do we put what type of thing it is? Like decomposition, synthesis.
Here.
What does it say?
Hmm?
What does it say?
Type.
Type.
Type. I always drop this bottle, and now I got water in my keyboard. Okay. So, that's for metal carbonate. Metal hydroxide.
And we have in the type we need to put decomposition metal.
Right.
chlorate.
No, you don't. You only decomposition. You don't have to put the type.
Oh, that's insane.
Mm-hmm.
Insane.
Metal oxide and water is what this one decomposes
Okay, so
into.
metal chlorate is the weird one.
Yeah. And it's easy to know it's a chlorate because there's a chlorine in the formula.
Yeah,
Like this
but-
one doesn't have a chlorine, this one doesn't have a chlorine, so you know you're not gonna have a chlorine here. This is the only one with chlorine in it, so you know it's metal chloride. And then what's left over? Just the oxygen, so you know it's oxygen O2.
Okay, so it's metal oxide and then water.
Yeah, and this one OH, doesn't that look like water? So then you know it's water, and then CO3 looks like carbon dioxide, CO2.
What you said did not make sense.
Okay, let me write it out first. So metal oxide, what's the metal here?
Man G.
And then with oxide is just
The metal is always first.
yes. So Mg is what charge?
2 plus.
And then with 2 minus, when I cross it, what do I get?
Cancels out.
NGO.
Right. And then water is what formula?
Oh.
H2O.
Okay. So do you see how here OH looks like H2O? It like has the same
I
letters.
understood what you meant.
Okay,
but-
good.
Yeah, but.
If it helps you, great. If it doesn't, figure something else out. Okay, and then I need states of matter for this one. So again, all metal oxides.
Or solids.
Metal oxides, all are solids.
Yep.
How could it's not?
Look at your reference sheet all the way at the bottom, the very last sentence. And then what about water?
Liquid.
But we can't. If Mg is not on or O,
No, what does it say at the very end?
yeah, but we're not gonna know that.
No, I'm just giving that to you on the quiz.
Oh,
I write it on the board.
You told us that you were only gonna give us this.
Yep, I'm giving it to you now. Okay, so that's decomposition. Metal chlorates decompose into metal chlorides and oxygen. This one, metal oxide and carbon dioxide. And then metal hydroxides, metal oxide and water. And then you have to just remember that.
And like, the recording hears my voice because I'm gonna have when I look at it again, I'm gonna have the same questions as now.
Yeah, it's gonna have your voice. Okay, single replacement is the next one. Okay, so you have to memorize these rules, or like this is not gonna do anything for you. You know, like I can give you a million examples, but if you don't memorize the rules, you're wasting your time.
What are your rules?
Like, do you know that all of them decompose into this or decompose into that? Okay, single replacement reactions. I'm gonna write the type at the top. So, metal replaces. Metal replaces
H in liquid or acid.
H in water or acid, or non-metal replaces non-metal. Okay.
Metal replaces metal. Metal replaces hydrogen in H2O.
Water,
Or acid.
or acid.
I forgot the acid was. We're gonna have a quiz on that.
It's gonna be on the exam. You're not gonna have a quiz on it though. Okay, let me do. Hold on, I need the activity series. No,
Is that a thing?
that's not possible. No, it's not
Combustion
possible.
synthesis.
That one's possible. It's not on the quiz. No,
What?
it's
That's
possible, but it's not going to be on your quiz. Okay. I have this, and then I'll do another one like that. H2SO4, and then okay. All right. Here are the examples.
But single replacement and synthesis is possible.
No, not possible.
And the last one, that one.
The last one is not synthesis. Remember, 2 elements for synthesis.
I'll have to compound.
Okay, so with the first one, metal. So how do you know if it's metal replaces metal, or metal replaces hydrogen, or non-metal replaces non-metal? You look at the plain element. Who's the plain element here?
Fe.
Iron.
Iron, Fe. How about here?
Ca.
Ca, and then how about here?
And then, no, F2.
F, right? So that will tell you what kind of reaction it is, because what kind of element is F?
Non-metal.
A non-metal. And non-metals or elements can only replace their same kind. So non-metals can only replace non-metals, and metals can only replace metals. Okay? This one, I have a metal, and he's replacing hydrogen, right? There's no metal here, it's just hydrogen. So it just depends if it's H2O or if it's an acid. Okay? This is a metal replacing another metal. There's no H, there's no non-metal that it can't replace. Okay? You have to use the activity series in order for you to determine if a reaction can happen.
What is that?
I'll tell you.
It's like blurry.
Right. I'm gonna copy and paste it into the thing. Hold on. Okay. This is the activity series. This will tell us if a reaction can happen. Okay, so pay attention. Metal replaces metal. Again, iron wants to kick out who? Nickel. Because it's a metal. Perfect. So,
CO3 is the polyatomic.
correct. So then I have to look at my list. Can iron kick out nickel?
Yeah.
How do I know? If it's higher on the list than the guy it wants to kick out, then it can kick him out.
Wait, so nickel can't kick iron, but iron can.
Correct. So if the reaction was written like this,
Nickel can't.
nickel can't, it would
What are
be no reaction.
Oh, and you're gonna give us stuff like that?
Too easy. But there will be that on your exam, but not on the quiz. Okay?
It's not that easy, it's tricky.
Right. So, but you have to use the activity series to check that.
You know chocolate?
Okay? So, Fe can kick out a nickel, correct?
Yeah.
So then I'll switch places. So now, who's by himself when they switch?
CO3.
Mm-mm.
No, nickel.
Nickel. Okay, and what's the next thing? Hi.
Cross charges
Right, with who?
with CO3 negative.
So CO3 is 2 minus,
2 minus.
and now it's with who?
Fe.
And iron is 2 plus, because I gave you the charge right there, right?
The parentheses is like the parentheses, like the Roman numerals is always positive.
Correct. And what's the formula you said?
FeCO3.
FeCO3. So then, using my activity series, can you tell me what type of compound this is? If it's aqueous or solid?
Fe or CO, no, CO. Yeah, it's aqueous. What? Oh no, insoluble.
Mm-hmm.
It's solid.
Good. Solid. And nickel, obviously, it's just a metal. Solid.
All metals are solids.
All metals are solids, yes.
Chocolate.
Except for mercury. Okay? So then look. The balancing. Iron, how many do I have here?
2.
Here? How many irons?
Oh, 1. Sorry.
1. And how many irons do I have here?
1.
1. So I don't need to balance it, right? It's fine. How many nickels do I have?
1.
1. 1 nickel, right? And how many nickels here?
1.
So it's balanced.
Yeah.
How many CO3s do you see?
1.
And how many CO3s here?
1.
So everything's balanced.
Yeah.
Chocolate.
Okay? Does that make sense what I just did? Okay, next one I have a metal replacing hydrogen. So my metal is calcium. Mm-hmm.
If Fe,
Mhm.
let's say the charge was plus, not 2 plus,
Okay.
how would it be written?
If Fe's charge was plus, I would have Fe2CO3.
Also, the 2 goes down.
Mm-hmm. Because the charges don't cancel out anymore. What if I had a 3 here?
Fe2CO3 parentheses 3.
Perfect. Perfect. Okay?
Chocolate.
Good. So then, that's that one. Next one, a metal replaces hydrogen in H2O or acid. So obviously, what is this one? An H2O or acid.
H2O.
Okay. So do you remember whenever we would write water? Water would be made up of H plus and OH minus. Do you remember?
Yeah.
What's the formula? HOH. Okay, keep that in mind. Water is actually written HOH. We just make it look H2O.
Why?
Because H plus and OH comes together and makes HOH when we cross the charges.
Hydroxide and
H.
hydrogen.
Yeah. So look over here. To get the formula of Ca, pretend we have HOH for a second. Again, calcium is replacing who?
But
The H.
The H.
OH.
Oh wait, no, because it's canceled. Yeah. OH is one thing, H is another thing, right? So H and Ca are switching. Can it switch?
Yeah.
Can calcium and hydrogen switch?
Yes.
Yes. Because calcium is more higher on the chart, right? Okay. So then who's by himself?
H.
H, and then I have to put A,
2.
because it's,
Diatomic.
okay. And then who's Ca with?
OH.
OH. So Ca is 2 plus, OH is minus. What's the formula?
Ca parentheses OH2.
Perfect. Does that make sense?
Give us that chart.
Yes. Can you tell me the state of matter of CaOH2?
CaOH2. OH. Yeah. it's isn't it an alkali metal? CA.
No, it's not.
Okay, then it's solid.
No, it's aqueous.
But you see, what's next to the alkali metal? There's other elements there,
Oh, CA.
right?
Aqueous.
So it's what?
Aqueous.
Aqueous.
Good. You want to keep that?
It's solid. It's insoluble, but it's an exception.
Right. And then H is what? H2 is what?
Gas.
Gas. Okay, good?
Yeah.
All right. So the other one, an acid. What makes something an acid?
If it has H.
Right, if it has H in front, and I can have binary or oxy acids, depending, on what kind. Here, this is oxy acid because I have oxygen in it and a polyatomic. But that doesn't matter for this. Same thing.
But never mind. I forgot the question.
It's okay. So calcium wants to replace hydrogen. We already said it can. They're going to switch places. Who's by itself?
Hydrogen.
Hydrogen again. It's a gas. We already said. And calcium is now with who?
Ca and CO4.
SO4. So Ca is 2 plus. SO4 is 2 minus.
No, 3.
PO4 is 3. So then it cancels out and I get CaSO4. Can you tell me the state of matter of this?
It's Ca. Right here.
It's aqueous.
Mm-hmm.
Why? Oh yeah, SO4.
SO4 is soluble. Okay, by the way, all of this is wrong. Why is it all wrong?
It's not balanced.
It's not balanced. None of this is balanced. We haven't balanced it. I'm trying to save time here. But yeah, you're going to balance everything on the quiz. In order for it to be correct, it has to be balanced. Okay, does that make sense?
Yeah.
Okay, good. All right, and last but not least, I have a non-metal wants to replace who?
A non-metal.
Who? Which one?
Bromine.
Bromine, because he's the only non-metal. Can fluorine replace bromine using this activity series? Can fluorine replace bromine?
Yeah.
Yes, fluorine can replace bromine because it's higher on the list, right?
Yeah.
So they switch places, and who's by himself now?
Na.
Mm?
Wait, no.
Non-metal replaces non-metal.
So fluorine is replacing bromine.
Bromine.
Who's by himself?
Oh yeah, fluorine replaces bromine. Not bromine, fluorine. Oh yeah, it's the same thing.
Right. Who's by himself? Bromine. Right? Because this guy, he's going over here,
Oh, yeah.
and then bromine is going over here, right?
Can you not put the charge for the first one?
What do you mean?
Like bromine is it's negative.
Right, and then, but Na is
You don't put
positive. Na is positive, so what happens?
Oh, this one's well.
All the compounds cancel out. Br2 plus, and then I have Na is now with who?
F.
And Na is plus, F is minus, I get NaF. This is aqueous according to my chart. Bromine's a liquid, not a gas.
Why is it Br2?
Brinkelhoff?
Wait, you said it doesn't matter like the order.
No, does not matter.
Miss A. We
Yes.
have to remember that bromine is a liquid.
Yes, you do.
Okay.
I don't know if it's on the quiz. There's 2 versions of the quiz. I'm not sure if I put bromine in
Can you
there.
write that in the doc,
Yes,
please?
sure. Okay. Is okay. All right, that's single replacement. Any questions on that one?
No.
Okay, and then last but not least, double replacement.
Brinkelhoff sucks.
No, it doesn't. Easy. Okay, and then double replacement is just 2 compounds.
Just?
2 compounds.
Wait, single replacement? Can you like pull up a little bit?
Compound and an element.
You want me to put the formula?
What for?
Like what we did over here?
Yeah.
Okay. Yeah, compound and element. So,
AB equals A plus like
well,
plus
A plus B, and then we put X, and then they switch. So then what would it be?
B plus AX.
Yeah. Okay?
Why is this hard, bro?
It's really not. You're answering all the questions. How is it hard? Okay, double replacement is A and B is a compound, and they react with CD, another compound. So if this is an ionic compound, what does the A represent?
A cat.
A cation, and B?
A anion.
And then what about C?
Wait, what?
Cat,
Anion.
and.
Wait, Miss Ann,
Mhm.
sorry, what'd you say the formula for single replacement was?
Up here. So remember, this is double replacement is 2 ionic compounds reacting together. Ionic compounds are made up of cations and anions, like Na plus and Cl minus. Does that make sense? This is the cation, this is the anion. The cat is always written first, and the anion is always written second. Okay? So,
On a compound. In a compound.
how do you get the products then? You switch the anions. So B is an anion, D is an anion. They switch. So now A is with who?
D.
And C is with?
D.
Perfect. Okay? That's how you make the products.
So double replace it, you just replace the second
One.
in the compound.
Right. The second whatever in whatever compound, yes. So look at this. Let's do an
Usually
example.
it's an element, but it can be a polyatomic.
Right, exactly. So we'll do an easy
Polyatomics
one.
suck. Can you use a chart?
No.
If you pay tickets. That's smart.
Mm-mm. Let me give some like hard ones, I guess. Okay. So, in the first one, who's switching?
Cl and NO2.
Sorry.
Cl and NO3.
Yes.
2 negative.
Why 2 negative?
NO3 is minus.
NO3 is minus.
Bro, I don't know. I'm just guessing.
You're not guessing, good.
I know.
So they're switching, right?
Yeah.
So NO3 is now with who?
Na
Na is what charge?
plus
And NO3 is?
minus
So what's the formula?
NaNO3
NO3
Okay, and then what's the second product?
plus AG.
Ag is with is what charge, do you know?
AgCl.
Ag is plus, Cl is minus. This you have to memorize. Okay?
What?
AgCl. Remember, there's three
Exceptions.
exceptions to the transition metals. So
The entire
Ag,
exceptions.
zinc, cadmium, and silver. Those charges you have to remember.
What? That they're.
Always the
Just
same.
remember their charge. They have the same charge every time. They don't use Roman numerals. Okay? So there's my products. Now, can you tell me the state of matter of NaNO3?
NaNO3.
Mm-hmm.
Aqueous.
Aqueous.
Mm-hmm. How about AgCl?
Ag.
Solid.
Or CO. Yeah. That's
Solid.
what you said.
Right, because it's Cl is aqueous, but Ag is the exception, so it switches to solid.
I hate except. Why is there exceptions in chemistry, bro?
Exceptions in
Chemistry sucks.
everything.
I don't like chemistry. I'm just good at it.
Okay, I have one Na, one Na. I'm good. How many Cl?
1.
And how many Cl? So I'm good. How many Ag?
1.
How many Ag? Now, how many NO3s total?
1.
And here?
1.
So everything's balanced, right?
Yeah.
Oh, when you balance it, bro.
Hmm?
When
Every
you balance it.
Mm-hmm.
every question is gonna need balancing.
Yeah.
I figured it up there.
Okay. Now, who's switching here?
OH and PO4.
Right. OH and PO4 because they're the negative ones, right?
Yeah.
Okay, so OH and PO4, they switch. So now, Fe is with who?
With PO4.
Right, and what's PO4's charge?
3 minus.
But wait, do you like ignore that there's 2 PO4s?
Yes, because where does the 2 come from?
Ca.
Mm-mm.
Oh.
So OH is minus. Fe, we don't know the charge because it's a transition metal.
Yeah, it's 2.
But it's
plus.
2 because you uncrossed it, right?
No, I know it's 2 plus because I always see Fe with the parentheses.
But it can also be 3 plus. So, yeah, it can be both. Fe uses Roman numerals. So, to get the charge of Fe, you have to uncross the charge. So, Fe is actually a 2 plus charge here. So, what's the formula?
Fe3 parentheses PO4 2.
Perfect.
Bro, why are you so smart? Like, chill.
It's
I
true.
want to learn too.
And then, what's my next product?
I get the compliment, but I'm getting pissed.
Next product? So, they
CA
switched.
Ca and OH.
Perfect. What's OH? Sorry, what's CA's charge?
2 plus
2 plus.
And then what's OH's charge?
minus
What's the formula?
CaOH2
Mm-hmm.
parentheses.
So what's the state of matter of this guy right here?
Aqueous.
Yeah. Yeah, it's solid. No, it's
Wait,
aqueous.
which one are we
It's
talking
aqueous.
about?
Fe3PO4.
Oh wait, no.
Oh,
It's
I thought we were talking about the OH one.
This one.
Solid.
Yeah, so it's insoluble and Fe is not here, right?
Yeah.
So it stays solid. Does that make sense?
Yeah.
Okay, good. So Fe 3PO4 is a solid. And then what about calcium? Hydroxide.
Calcium
Data
hydroxide.
matter.
That's the
That's a solid.
aqueous. That's aqueous.
Right, this one's aqueous.
I mean the aqueous, bro.
You have the chart.
I know, bro. I knew the answer.
Good.
That's why I said the wrong one.
Okay, I need you to look at this, Elisa, because it's gonna help you balance. Ready?
Yeah.
How many Fe here?
One.
Why are you teaching us?
Look, how many Fe here? I'm making your life easier.
One.
How many Fe here?
One.
Three.
Three, I mean.
How do I fix that?
Add a
Three
three
and,
in front
that
of
one,
the.
Okay.
But
Done.
That makes that one 6.
Okay, so then how many OHs do I have here?
2.
How can I make it 6?
3.
Three.
But then that changes what?
Yeah, and that's
Calcium.
good. That's about.
Okay, do you see why that's easier?
Yeah.
Okay, we're done.
Chocolate.
Everything's balanced.
There's 2 PO. Yeah, chocolate.
See? That's way easier. Does that make sense what I just did?
Yeah.
Okay, so you see these questions here? I want you to tell me the types of reactions of all 5 on your own on a sheet of paper.
Wait, but I forgot. I'm gonna learn this on tutoring.
And try your best. You know the formulas, the A plus B stuff. Tell me, what kind of reaction is it?
Just the reaction.
Just the type, and then we'll go through the products together.
That's synthesis. No,
Do I have
Decomposing.
To I know this
You know it?
paper, yeah.
decomposing. The last one.
Okay.
And then it's synthesis.
The first one is double replacement. Second
Why?
one is
How do you know? How do you know?
it has 2 compounds. KCO3 is a compound,
Mhm.
LiCl is a compound.
Mm-hmm.
Second one be combustion and synthesis.
Yeah.
Mm-hmm.
The third one is single replacement.
Mm-hmm.
Yeah.
The fourth is combustion. It has a hydrocarbon and an O2. And
Mhm.
the fifth one is decomposition.
Carbonate.
Beautiful.
Wait.
Beautiful.
The fourth one, it's because it has a carbon and hot, like hydrogen.
The hydrocarbon here.
Yeah, and then
Because this can't be single replacement. None of these elements are on the chart. The activity series. None of them are here. You know what I'm saying? It can't be single replacement. Single replacement is the only one that uses activity series. I'll put that.
no, that counts. It's hard. It's like a lot of information.
I know. That's why I gave you a lot of time to study it, and you're choosing to study the day before.
Yeah, I always do.
Not true.
Not you. Yeah. Not you guys.
I always do. I never did a homework like 2 days before it was due. Like I always do it the night before. It's a problem.
You should fix it before college.
No, yeah. No, in college I'm kind of like ooh.
Okay. So you guys said the first one was what again?
Double replacement.
Everyone agrees with that. How do you know it's double replacement?
Because there's 2 compounds.
Because there's 2 compounds. Okay, 2 compounds. Number 2,
Synthesis and combustion.
synthesis, because why?
It's 2 reactants.
Okay, but what are the reactants in particular?
A plus B.
Mg.
Elements. They're elements. They're
Oh,
plain
they're not
elements.
compounds.
They're not compounds. That's what makes it synthesis. And then what makes it combustion?
The O2.
The O2. Okay, number 3.
Single replacement.
No, single replacement.
Right, what kind? And
Compound and,
what kind do you think? What kind of single replacement?
Wait. What do you mean?
Metal replaces metal, metal replaces not.
Oh,
Non-metal replaces non-metal.
Wait, what's CA?
Metal replaces metal.
Metal, what's...
Yeah, SR is number 38 on the periodic table.
Yeah.
Yeah,
And
metal.
CA, they're both
Right,
metal.
so metal can replace only what? A metal or hydrogen.
Yeah.
Do I have any hydrogen here?
No.
No, so it must be replacing a metal.
What if there's some hydrogen and a metal?
No, it can't.
Okay.
Because they're both positive, remember?
No.
Okay, number 4,
Combustion.
combustion only. And number 5,
Wait. Why is it
Decomposition.
combustion? Because there's a compound and an oxygen.
okay. There's O2, makes it combustion.
Yeah.
And what else could it be then?
Synthesis? No, it's not synthesis.
No.
Which one, the last one?
No, number 4. You said why is it combustion? What else could it be?
It has an element, it has a compound and an oxygen.
Okay, so could it be something else besides combustion or no?
No.
No, just combustion. Okay, and then the last one?
Decomposition.
Because it's only what?
One.
One reactant. One thing
Yeah,
before the arrow.
AB.
What kind? Metal chlorate, metal carbonate, metal hydroxide, metal carbonate. Do you remember what metal carbonates decompose into?
What?
Metal
What do metal carbonates?
It's metal,
CO2?
oxygen,
Uh-huh.
and hydrogen. No.
No.
What does this look like?
Carbon
Oxygen.
dioxide.
CO2. Yes.
It's metal,
Oxide.
Metal oxide and
metal. Wait,
plus CO2.
I didn't say that.
You said metal oxygen.
Yeah.
Metal oxide, same thing, sure.
Metal oxide.
No.
It's metal, oxygen, and
CO2.
CO2, which is
Because CO3 looks like
carbon
CO2.
dioxide.
Okay, so what's my metal here then?
Na
Na
And then what's the charge?
plus
And then oxygen?
O
O, 2 minus. And then what's the formula?
Na2O.
Okay, and then all metal oxides are what?
plus CO2.
Are solids.
Uh-huh. And then the second product you guys said was what?
CO2.
CO2.
Oh yeah, no, the O is already there.
Mm-hmm. This is a what?
A gas.
Is it balanced?
My mom's asking me how much time we finished.
I mean, 10 minutes. Once we finish these.
Is it?
Yeah, it's
Na is
3:20 now.
balanced.
Yeah, everything's balanced.
Yeah.
Good. Okay, C. Sorry, 4. What is 4 going to be? The products.
4.
CO2
Wait.
plus H2O.
It's composite. It's combustion,
Okay.
which is a gas.
Mm-hmm.
It's a gas.
What's a gas?
It's the.
It's going to make gases, sure.
Yeah.
What are the, but what's made? What's being made?
It's A B. So it would be C H. What's C H?
H2O.
They said it. Remember, this is, you have to remember this. Right here, combustion reaction. I have a a hydrocarbon with oxygen. And what does it always make?
CO2 plus H2O.
CO2 plus H2O. No matter what type of hydrocarbon here, I'll always have CO2 and H2O. Even if I put oxygen with it, it's still gonna be CO2 and H2O. Does that make sense?
Yes.
Okay. I'm gonna put it here just as an example. Because there is one with oxygen on the quiz. Okay.
What? Can
There-
you read that?
There's one with oxygen on the quiz.
What do you mean with the oxygen?
Like with this.
Oh, one like O3 and then plus O2.
Mm-hmm.
I bet it's that one.
And it's a different one. Okay, so, well, here I am. So you guys said CO2.
H2O, no?
Yeah, does it matter the order? No. Okay, obviously, again, we have to balance it. How many C's on the left?
1,
Okay, how many C's on the right?
1,
Okay, how many H's?
4,
How many H's?
2.
Okay, how can I fix that?
Put a 2 in front of H2O.
Okay, what does that change?
Oxygen.
Okay, so now how many oxygens do I have?
4,
I have 2 over here, and then I have 2 over here. I have 4. How many should I have here?
4.
So what do I do?
Add another 2 in front of H2O.
Okay, is it balanced?
Yeah.
Yes. Okay, remember, it's producing gases. So this is going to be
A gas.
gas and gas. Good? Okay, next. Number 3.
Single replacement. So
Metal replaces a metal. The single guy wants to replace the other guy. Can strontium replace calcium?
Yes.
Can strontium replace calcium?
Yes.
Yes, because it's higher
I know
up.
it's yes, because you're not going to give us problems that don't.
Yes, that's true. So then who's by himself?
Calcium.
Right? And then who's with NO3?
And it's NO3
Stroke.
negative.
And then SR is what?
2 plus.
Mm-hmm. What's the formula?
SR parentheses NO3 2.
Mm-hmm. And then what's the state of matter here?
Aqueous.
Mm-hmm. And then what? Because NO3 is soluble. Because NO3. None. Okay, and then what else? Oh, and then what's state of matter for calcium?
A salt.
Yeah, and is it balanced? You tell me.
Wait, because calcium is a metal. That's why no solid.
Correct. Okay, how many
Yes.
calciums here?
It's balanced. 1.
Yeah, it's balanced. And here's 1. There's 2 NO3s, 2 NO3s, 1 SR, 1 SR. Cool? Okay. 2 more. Number 2, how do I do number 2?
Cross charges.
It's synthetic.
Mm-hmm.
Are they still the same?
Thank you. Yeah, it is. Because they didn't see them already, so. Bye, guys. Have a good day.
Thanks
Bye.
for having us.
Thank you, guys. Have a good day.
Take care.
You too.
I
MGO.
I
Yeah.
confuse synthesis with synthetic because I'm learning that in algebra too.
You confuse synthesis with
Synthetic.
MgO. Yes. Why? Why is it MgO as the answer?
Mg is 2 plus. So
Right. You have to
2
cross the charges here. So 2 plus O2 minus. That makes
Cancel out.
MgO, and they cancel out. And then all metal oxides are what?
solid.
Okay. Is it balanced?
No.
How do I balance this?
Added 2 in front of the MgO.
And
And in front of
Mm-hmm.
the, yeah.
Perfect.
Synthesis is the easiest one.
Right.
You just cross charges.
Correct. How about number 1? How can I do number 1?
It's decomposition.
Right.
What?
No.
It's
No.
double
No. Sorry.
replacement.
I put a D. I should put DRR.
You switch the cation. I mean the anion.
Yes. What are my anions?
CO3 2 negative.
Mm-hmm.
Vamos.
And?
Cl
minus.
minus.
So now, he is with who?
K2.
So K is what?
K is
Plus.
Plus. So KCl. Perfect. Okay. And then, this guy is with who?
Li.
Li. So Li is what charge?
Plus.
And then together they make what?
Li2CO3.
Li2CO3. Can you tell me the state of matter of that?
align.
Solid. Is it all? No.
Mm-mm. Look at it again.
Is it a metal oxide?
No, it's not a metal and oxygen, it's metal and carbonate.
Wait, CO3?
Li, guys, look at your charts. I see Li on the chart right there.
Is it a metal?
Oh,
is it
I'm
a,
looking
is
at
it
the
an
bottom.
alkaline?
Yeah, it's aqueous. It has
LiCO3. Li is right here.
Yeah.
So
Aqueous.
CO3 is in the insoluble.
Okay, so CO3 is insoluble. But an alkaline metal is what we have. We have
Oh, it's an
lithium.
alkaline metal?
So it becomes soluble. Okay, good. And then KCl?
It's solid. It's aqueous.
Aqueous.
Yeah, because it's K and there's no exceptions. So we're
Okay.
done?
Is it balanced?
No.
How many K here?
2.
How many K here?
1.
How can I fix that?
Add a 2 in front of KCl.
Mm-hmm. How many CLs do I have now?
2.
So how should I fix that?
Put a 2 in front of LiCl.
Who else does that change?
Cl.
And Li. So now Li has 2. Does Li have 2 here?
Yeah.
So everything's balanced?
Yeah.
CO3 is balanced?
Yeah.
Yes. Okay. That's it. If you guys have any, if you want to do more, if you have any other questions, you can ask me, but that's basically,
Wait,
that's
can
basically
you
it.
put in the document that H2O when it does combustion is gas?
Yeah.
and it's not liquid?
Miss Rose, single replacement is like the only one that
Thanks,
has
Miss
single
A.
element and then a compound.
Correct. But don't get confused, like the hydrocarbon combustion looks like an element in a compound also, but you don't do that with them because they're not in the activity series.
You said, can I take a picture of the periodic table?
Yeah, I think he put it in the group chat. Yeah, it's in the group chat.
Thank you.
You got every single answer correct, Mumia. I don't know why you were scared in the first place.
Ah, okay.
When H2O is in a combustion reaction, it will be a gas.
Wait, are you gonna airdrop this or are you gonna put it in the?
You want me to airdrop it to you guys right now?
Yes, please.
A girl asked to send it.
Okay, so I guess I'll just send it.
Okay.
You guys want me to send it to them?
Yes.